Welcome to STEMsphere. In this video, we'll explore measurement of AC and DC bridges in electrical engineering. Bridge circuits used for the measurement of self-inductance, capacitance, mutual inductance, and resistance. DC bridges. DC bridges are electrical circuits that operate using only direct current, DC, voltage signals. They are primarily used to measure the value of an unknown resistance present within the bridge circuit. Classification of resistance. Classification of resistance based on its value. 1. Low resistance. Resistances with values typically less than 1 ohm. Second, medium resistance. Resistances with values between 1 ohm and 100,000 ohms. 3. High resistance. Resistances with values greater than 100,000 ohms. Overall, DC bridges are valuable tools for accurately measuring unknown resistances in various electrical circuits, and the classification of resistance helps in understanding the different ranges of resistance values encountered in practical applications. The methods used to measure low resistance. It lists 4 primary methods. Kelvin's double bridge method. This method is commonly used due to its accuracy and ability to minimize errors caused by contact resistance. It involves balancing 2 Wheatstone bridges to determine the unknown resistance. Potentiometer method. This method is based on the principle of comparing the unknown resistance with a known standard resistance. It offers high precision but requires a stable voltage source and careful calibration. Ductor-ohmmeter. This is a specialized instrument designed to measure low resistance directly. It provides a convenient and efficient way to measure resistances in various applications. Ammeter-voltmeter. Method. While not as accurate as the other methods, this involves measuring the current flowing through the unknown resistance and the voltage drop across it, using an ammeter and voltmeter, respectively. The resistance can then be calculated using Ohm's law. The methods used to measure medium resistance. It lists 5 primary methods. 1. Ammeter-voltmeter method. This involves measuring the current flowing through the unknown resistance and the voltage drop across it, using an ammeter and voltmeter, respectively. The resistance can then be calculated using Ohm's law. Wheatstone bridge method. This method is based on balancing a bridge circuit to determine the unknown resistance. It offers high accuracy and is widely used for precision measurements. 3. Substitution method. This method involves replacing the unknown resistance with a known standard resistance and comparing the readings to determine the unknown value. 4. Carey-Foster bridge method. This is a variation of the Wheatstone bridge method that is specifically designed for measuring small differences in resistance. 5. Ohmmeter method. An ohmmeter is a specialized instrument that directly measures resistance. It provides a convenient and efficient way to measure resistances in various applications. The methods used to measure high resistance. It lists 4 primary methods. Loss of charge. Method. This method involves charging a capacitor through the unknown resistance and then measuring the rate at which it discharges. The time constant of the discharge can be used to calculate the resistance. Mega. A mega is a specialized instrument designed to measure high resistance directly. It provides a convenient and efficient way to measure resistances in insulation systems. Megohm bridge method. This is a variation of the Wheatstone bridge method that is specifically designed for measuring high resistances. It offers high accuracy and is often used in insulation testing. Direct deflection method. This method involves directly measuring the current flowing through the unknown resistance using a sensitive ammeter. The resistance can then be calculated using Ohm's law. What are AC bridges? AC bridges operate using alternating current AC voltage signals. Unlike DC bridges, which primarily measure resistance, AC bridges can measure both the magnitude and phase angle of an unknown impedance. This makes them versatile for a wide range of applications. Impedance measurement, AC bridges, are used to measure the following electrical quantities. Inductance, the ability of a component to store energy in a magnetic field. Capacitance, the ability of a component to store energy in an electric field. Frequency, the number of cycles per second of an alternating current. How AC bridges work. AC bridges typically consist of 4 branches, each containing a combination of resistors, capacitors, and inductors. By balancing the bridge, we can determine the unknown impedance. This involves adjusting the components in the bridge until the voltage at the null point becomes 0. Applications of AC bridges. AC bridges have numerous applications in various fields, including electronics, measuring components like resistors, capacitors, and inductors, telecommunications, testing cables, and other communication equipment, power systems, analyzing power quality and fault detection. AC bridges are powerful tools for measuring impedance and other electrical quantities. Their versatility and accuracy make them indispensable in many industries. The methods used to measure inductance. It lists 5 primary methods. 1. Maxwell's inductance bridge. This is a common method that involves balancing a bridge circuit to determine the unknown inductance. 2. Maxwell's LC bridge, or Maxwell's Wien bridge. This is a variation of the Maxwell's inductance bridge that is specifically designed for measuring the ratio of inductance to capacitance. 3. Hayes bridge. This method is used to measure the inductance of a coil with a known resistance. 4. Anderson bridge. This method is used to measure the inductance of a coil with a known capacitance. 5. Owen bridge. This method is used to measure the inductance of a coil with a known mutual inductance, the methods used to measure capacitance. It lists 2 primary methods. 1. Sharing bridge. This is a common method that involves balancing a bridge circuit to determine the unknown capacitance. 2. De Sauty bridge. This is a variation of the sharing bridge that is specifically designed for measuring high capacitances. 1. Wien's bridge. This is a common method that involves balancing a bridge circuit to determine the unknown frequency. Wien's bridge is a type of AC bridge circuit that is specifically designed for measuring frequency. It consists of a resistor, a capacitor, and an inductor connected in a bridge configuration. By adjusting the components in the bridge, the frequency of an unknown signal can be determined.